Okay, hello. We're talking today about the metric system or System International. That's SI. It's a French thing. That's why they say System International. And what we're going to do is talk about why we use the metric system, what we can do with the metric system, and how the metric system works. So let's start with why do we use it? Well, the metric system is used by scientists all over the world. It was decided a long time ago that the metric system would be the one common thing that all scientists do, so there's no arguing over which units are the more important ones. It was decided, and that's the International Union of Scientists, or the System International. The next reason we use the metric system is that it's easier than our system. We use what's called the Standard American English System, or SAE system. And if we look at the comparison of SAE to metrics, we end up with something that looks a little bit like this. In SAE, 1 mile equals 5,280 feet. In metrics, 1 kilometer equals 1,000 meters. Now, as you can see, 1 kilometer being 1,000 meters is a pretty easy change. All we do is move the decimal, whereas in the SAE system, to change from 1 mile to 5,280 feet, we have to multiply by random numbers. And we don't like that. Moving the decimal is easy. That's why it makes us happy. And apparently it makes our head funny shaped. Okay, the next question we have is, what do we measure with metrics? Well, in metrics we can measure anything. So if we take a look at what we can measure with metrics, we can talk about the base units, we can talk about the abbreviation for those base units, and what they're actually measuring. So let's talk about first the meter. The meter is abbreviated with a lowercase m, and it measures length. How long is something? Well, it's 2 meters long. So we'd abbreviate with a lowercase m, and we know when we're talking meters, we're talking about length. After length, we've also got liters, which are abbreviated lowercase l, and they measure volume, which is another way of saying size or how big something is. We have grams, which is a lowercase g, and grams measure mass, which is sort of the same thing as weight. As long as we're staying here on Earth, mass and weight are kind of the same thing. We can measure seconds, which is a lowercase s, and that measures time. And in temperature, when we measure temperature, we have 2 ways of doing it. Celsius, or degrees Celsius, which is this abbreviation here. Or we have kelvins, which is the K measure. They both work out the same way in the math, but they're treated just a little bit differently. But those are the base units of the metric system. And we can use, in the next frame, we'll talk about the prefixes for counting in the metric system, and we can use anything for those, and I'll explain that in a moment. But for now, just know these are the base units we'll be using a lot of: meters, liters, grams, seconds, Celsius, and Kelvin. So when we talk about the prefixes, the first one, when we're dealing with prefixes that represent larger than 1 unit, like a meter or a gram, etc., is going to be deca, which has a value of 10, and it means, or it is abbreviated with a capital D, as in a decameter being 10 meters. Above that, we talk about something called the hecto, there it is, hecto, which has a value of 100 and is a capital H. If we had a hectogram, which would be H lowercase g, equals 100 grams. Other values are kilo and mega, which kilo we'll use a lot. Mega we use infrequently. You hear that like in megabytes in computers and things like that. Kilo means 1,000 and mega means 1,000,000. So a kilometer is 1,000 meters and a megaliter would be 1,000,000 liters. Again, mega is not thrown around very often. Dealing in millions is a lot. Now for values less than 1 unit, less than 1 meter or 1 gram or 1 second, we have their prefixes, and those are in lowercase. Lowercase abbreviations like here or here, here, and this one's a script. But deci is 1/10 or 0.1, so 10 decimeters equals a meter. There are 10 decimeters in 1 meter. Centi, or 1/100th, which is 0.01. Milli, 1/1000th, or 0.001. And micro, another one we won't be using very often, but you'll hear it in later science classes where we talk about 1/1,000,000th of something. You could have a microsecond or a microliter or a microgram. These are very small amounts, but sometimes they're very, very important in science. Now when using the decimal system, sometimes it's necessary to convert from one prefix to another. For instance, you might have measured something in centimeters, but you need to convert it into kilometers. Or you've measured it in milliliters, and you need to know what that translates to in regular liters. Now you can't convert from liters into meters. That's not how it works. But you can convert milliliters into liters. And the way you do that is just simply moving the decimal. This chart was used forever in figuring out how to do that. It's very helpful. There's an old mnemonic device where you can talk about King Henry died drinking chocolate milk. Kind of silly, but it works. And we'll show you how to use that here. Now our example problem says 5.25 km, which is kilometers, equals blank cm or centimeters. So we're going to try and figure out how many centimeters make up 5.25 kilometers. And we can do this in 3 steps. In the first step, we start in the chart here on the prefix letter that we have. And that's going to be kilo, which is right here. We're just going to put a little dot there to say that's where we're going to start with our finger. The next step, step 2, is we count jumps to the prefix letter in our answer. So we're here at kilo, and we're going to jump 1, 2, 3. We count the base unit, 4, and 5 to the right side. And for the final step, we're going to move the decimal in the problem the same way. So here's our decimal in the problem. We're going to move it 1, 2, 3, 4, 5 spaces, and our solution is 5, 2, 5, 0, 0, 0 centimeters. 525,000 centimeters is equal to 5.25 kilometers. That's how we convert. Now we'll try a couple of sample problems. 64.7 milliliters equals how many liters? And again, we have our Henry died. There's our units, drinking chocolate milk. And in this problem, we're going to have 647. And I know that our decimal point is right here, right there. So we're going to go from milliliters to liters, which is right here, base unit. That's a jump of 1, 2, 3. So we're going to jump 1, 2, 3. So our answer is 0.0647. The next one, 450 grams. Well, we're going to write our 450, our decimal points right here. We're going from grams, which is a base unit, to kilograms. That's a jump again of 1, 2, 3 spaces to the left. This time we're going left. So we're going to go 1, 2, 3 spaces, and it is 0.450 kilograms. And 7.2 milliseconds to seconds. Again, 3 spaces to the left. We would write 7 and 2 and move the decimal 1, 2, 3 spaces to the left, and it's going to be 0.0072. That's how we do these problems. Thanks a lot, guys. Good job.